Good morning, dear member of the Gairdner Foundation, Dr. Eisenhauer and colleague. My name is Bertrand Routy. I'm a clinician scientist and Canadian research chair at the University of Montreal. I'm very pleased and honored to receive the Gairdner Young Investigator Award for my work linking the gut microbiome to cancer immunotherapy. Immune checkpoint inhibitor represent an unparalleled paradigm shift in oncology. More than 50% of patients will be treated with immune checkpoint throughout their cancer journey. Despite the significant increase in overall survival in melanoma and non-small cell lung cancer, the majority of patients still continue to progress. Several factors, also known as cancer-related set points, have been associated with resistance. Today, I'll focus on the gut microbiome. Indeed, as you know, we are covered by bacteria, and we have more bacteria cells in our gut than the human cells in our body. Interestingly, the gut microbiome has been associated with a myriad of diseases, such as inflammatory bowel disease, obesity, multiple sclerosis, and more recently, cancer. Indeed, our team pioneered the concept that the antitumor efficacy of immune checkpoint inhibitor requires gut bacteria. In these pivotal experiments, we inoculate a tumor in the right flank of a mice, and you see that if you give immune checkpoint inhibitor, here anti-PD-1, the tumor size are significantly decreased. In parallel experiment, if you give broad spectrum antibiotics, you get rid of the gut microbiome, you see that you completely lose the anti-cancer effect of PD-1. Similarly, in germ-free mice who live in bubbles without any bacteria, immune checkpoint activity is inhibited. We then address the same question in our cancer patient, and we're very surprised to see that in patients with non-small cell lung cancer, those that receive antibiotic 1 month prior to initiate their immunotherapy actually had a shorter overall survival. This very provocative paper was actually validated, and we published recently a meta-analysis of more than 34 studies, including close to 12,000 patients. And you see in this study, almost all of them, except 3, demonstrated that antibiotic prior to immunotherapy initiation had a deleterious impact on overall survival. This changed routine practical medical oncology. We then perform metagenomic in order to sequence and characterize the bacteria present in the gut of our patient. And our first paper, we demonstrated in non-small cell lung cancer that the bacteria Akkermansia muciniphila was enriched in patients with good objective response. We recently published a validation paper, this time in 338 patients with non-small cell lung cancer amenable to immunotherapy. And you see that patients with Akkermansia muciniphila in their feces had a better response, represented by complete response or partial response, compared to patients without Akkermansia muciniphila in their feces. We then want to modify or improve the gut microbiome of our patient. In this first experiment, we transfer microbiome into mice in order to humanize the microbiome of mice and then to do some modification. You see that if you take feces from non-responder, you transplant their feces in mice, immunotherapy does not work. Conversely, when you take feces of patients with very good anti-cancer response, in our murine model, we can replicate this response. Importantly, what we've pioneered and done is to change the microbiome of non-responder patients in mice, and then we added either a probiotic, so this time is a bacteria Akkermansia muciniphila, or another transplant from a patient in complete response. And by modifying the gut microbiome, we're able to restore immunotherapy response. This led to a lot and a very exciting clinical trial where the microbiome is at the center, and we're trying to develop different strategies to improve the gut microbiome, improve Akkermansia or other bacteria such as Ruminococcus or Bifidobacteria. Of course, this is the reaction you probably have when I'm telling you that in Montreal, we gave fecal microbiota transplantation in patients with metastatic melanoma. in combination with immunotherapy. And one of the first patients in our trial wanted to give you her experience with our transplant.
Ça a super bien été. Ça m'a surpris. Je pensais que j'aurais de la difficulté, que ça ne passerait pas. Mais non, ça a très bien été. Je veux dire, et ça allait très bien. En tout cas, je trouve que si d'autres personnes peuvent faire, si on peut apporter des résultats positifs, j'espère que d'autres personnes vont suivre. Je pense que c'est un peu plus d'espoir que ça donne à notre vie.
So you see that it's not that dramatic to receive a fecal microbiota transplantation. We put feces in 3-layer coated capsules, and patients take that right before starting their immunotherapy. I'm happy to tell you that we completed our first trial in Canada, and we are opening next month 3 additional trials.
That's good.
Indeed, we're now working on different strategy to modify the gut microbiome in the lab, but also rapidly in our cancer patient. We have now, with the support of the Canadian Cancer Society, 2 additional fecal microbiota transplant trials. We're hoping to open the Akkermansia muciniphila probiotic trial. And through the support of the Western family, we're opening next month a trial with a prebiotic, which are chemical compounds that positively modify the gut microbiome. Indeed, through my time with Dr. Eisenhauer, we exchanged at length, and I really benefited from her experience with regard to how to design this novel clinical trial. And I'm happy to tell you that thanks to her support, I will meet the group of CCTG, the Canadian Cancer Trial Group, next month, and we hope to bring to the CCTG randomized fecal microbiota transplantation trial in Canada. Therefore, in conclusion, I hope that I've been able to convince you that the gut microbiome is very important in cancer oncology. And we had actually a very rapid development, because this is a paper that was published in Nature. And when I started my PhD in Paris in 2015, you see that people, especially physicians, were extremely reluctant to help us to collect fecal sample from our patients. And I had a very not cute nickname, but it was Mr. Caca. However, you see that over the last 6 years, the field has changed drastically. We have now clinical trials that show how modification of the microbiome could potentially restore immunotherapy efficacy. Solange Peters, the president of ESMO, now includes the microbiome as a novel prognostic marker of immunotherapy. And you'll see that over the next few years, a lot of various trials and different strategies will open in Canada and around the world in order to improve the gut microbiome of our cancer patients. In conclusion, of course, I would like to thank my entire team. They work days and nights despite COVID in order to improve and to bring new strategies in our murine experiments, but more importantly, for our patients to increase overall survival. Once again, thank you very much, Dr. Eisenhauer, for your feedback, and for the Gairdner Foundation for their support.